Okay, so now for some examples of graphing in radians. For this first equation that they give us right here, we want to pull out all of the dilations and translations. So if I look at this 3 right here, this 3 is added onto the tangent, so it's vertical translation. It's a translation because it's added on, and it's vertical because it's outside of the tangent. So vertical translation of 3. In this case, there is no vertical dilation. I didn't stretch it at all. If you want to talk about a vertical dilation, you can say none, or you can say, gosh, I must have just multiplied by 1. So moving on to the other part, the other piece I see, the other transformation I see a 2x here. I know since the 2 is multiplied on, it's a dilation. So our horizontal dilation in this case isn't 2, but it's 1/2. Because we said that when we were doing horizontal dilations and horizontal translations, they're always backwards. The reciprocal of the dilation is in the equation, so the actual dilation is a 1/2. So this is going to squish to be skinnier than usual. And then horizontal translation, again, you could put none, or if I don't shift left or right, I've shifted by 0. Okay, I've shifted 0. I haven't shifted any. So it depends on if you're dilating by 1, not to change anything, or you're shifting by 0. You're translating by 0. You're adding or subtracting 0. So I've got my vertical translation dilation pieces. I want to draw my guidelines. So the vertical translation means my middle guideline is now shifted up 3. So that middle guideline is going to be at 3. And then after that, my vertical dilation is 1. I didn't dilate it any, so it should still be 1 above and 1 below for the upper and lower guidelines. So just using some of these guys. I needed it in gray. I need it smaller. Move this out. Oh, I can't move that out of the way. Ooh. All right. Anyway. Undo. Try again. Dotted lines. Gray. I got one. Oh, come on. Choose gray. All right, whatever. And then we have another guideline here and another guideline here. And then based on this then, I've got my vertical y values placed on there. I also need to look at my x values here because this is the x-axis. So I know my dilation is 1/2. I've not translated anything, so I'm going to start at 0, and I've got to figure out what my period is to figure out where I end. If my dilation is 1/2, to figure out the new period, I take the regular period for tangent, which was pi, and multiply by 1/2. So pi over 2. The period for this graph isn't pi anymore. We've squished it down by 1/2, and now it's pi over 2. So let's say pi over 2 is right here. That's where my period is going to end. So halfway through, 1/4 of the way through, 3/4 of the way through, I divide it into 4 equal pieces. 1/4 of pi over 2 is pi over 8. So 1/8, 2/8, 3/8. 2/8 simplifies into 1/4, so pi over 4. So those are the theta values, or sorry, not theta values, x values, my radian values. That would be the 5 important points and asymptotes to plot. For a tangent, we know that tangent doesn't start with an asymptote, it starts with a point. It starts with a point on that middle guideline, right there. Then 1/4 of the way through, we'd be on the upper guideline. Then we'd have an asymptote in the middle. Then we'd on the lower guideline, and then on the middle guideline again. We are here concave up, and here concave down. There's one period of that tangent graph, and we know we can keep on going and plot some more points and plot some more asymptotes, and we get the rest of the graph. Keep on going this way. Okay, so we have at least one full period of tangent there, marked out where specifically the first period is from 0 to pi over 2, and vertically with my 3 guidelines there. Okay, so that's to go from an equation to a graph. Find all your vertical dilations, translations, put all the points on there like we used to do with the 3 vertical or y value guidelines, the x values here, 5 important points and asymptotes, and then do your pattern, connect them all up. So this one right here, let's go from graph back to equation. In this case, the graph to the equation, I've already got some of these points labeled. So this one is at 4, This one is at 1. This one down here is at -2. So you can see where those guidelines would be, right? These three guidelines, the middle guideline is at 1. That means my vertical translation was 1. I've shifted it up 1. Because my upper guideline and lower guideline are 3 above and 3 below, we can't call it amplitude anymore, but it is our vertical dilation. They used to be 1 above and 1 below. Now they're stretched to be 3 above and 3 below. Okay. Also, we have to look at the period here to find our horizontal dilation translation pieces, right? So if you look at the scale, this asymptote is at 3. This one's over here at -4. This one over here at 10. We don't need to go all the way from -4 to 10 to be one full period for a tangent or cotangent. One full period of a tangent or cotangent, well, in this case it's a cotangent, would be everything between these two asymptotes. This is one full period or one full cycle right there of a cotangent graph. So the period here from -4 to 3, the period is 7. So since the period is 7, I need to find my horizontal dilation, right? We know that the little formula says that my new period, I always find that by taking the regular period and multiplying by that horizontal dilation. I don't know the horizontal dilation, so I'll call that d, but I know the regular period of a cotangent is pi, and the period of this graph is 7. So solving that for d must have been 7 over pi. This horizontal dilation is 7 over pi. So when we put it in the equation, it's going to be pi over 7. We have done a horizontal translation. If I look at this, now my period here goes from -4 to 3. So I must have, instead of starting at 0, I must have shifted it back to -4. I could have also shifted it forward to start at 3, because then this could be my one cycle of our cotangent instead of the other one. It doesn't really matter which one you use. Both will work. So to use these vertical dilation translation pieces now to write the equation, I start with y equals my vertical translation plus my vertical dilation. This is a cotangent graph because it always decreases. We know cotangent starts and ends with an asymptote, so that's why I picked those pieces there. My horizontal dilation is 7 over pi, so we put pi over 7 in here. X minus, oh no, plus 4, because we've moved it to the right 4, or to the left 4. So there's the equation based on that graph right there. Let's quickly run through our third example here with our cosecant graph. Okay, so again, vertical translation, pull that number off, that's -3. Vertical dilation, that's the 5. Horizontal dilation is the next number here, except we need to do the reciprocal. So 2 pi over 3, the reciprocal is 3 over 2 pi. And then the last number here, the horizontal translation, is going to be 1. 1 radian, not 1 degree. Now we're not going to do any converting between radians and degrees. This is in radians, period. So we talk about the new period equals the regular period times that horizontal dilation. I know the regular period for a cosecant graph in radians is 2 pi. I know the horizontal dilation is this 3 over 2 pi, which means my new period here, the 2 pi's cancel, and I just get a period of 3. Okay, so my period for this is 3. 3 radians is how long it takes to go through one full cycle. We need to draw our guidelines on here. So I go back down here and let's see here. Okay, so vertical translation of -3. 1, 2, 3, -3. My vertical dilation, I need to go 3 above, or sorry, 5 above and 5 below that. 5 above, 5 below, to right there. So those are where the guidelines are going to be. So guidelines. Oh, come on. Try again. Let's do it in gray. So, oh, come on. Oh, I know why that's doing that. Undo, undo. Okay, let's try this again. Line, dotted line, gray, Make it skinnier. There we go. So guideline, guideline, guideline. All right. So now I've got my three guidelines on here. I need to put the X scale on here now. I know I need to start over here at 1. So let's say that's 1. I know my period is 3, so I need to go 3 farther forward. So my period is going to end at 4. That's not much of a period there. Okay. For a cosecant graph, any of these graphs, we need to take our period and break it into 4 equal pieces. So if my period is 3, then 1/4 of my period is 3/4 or 0.75. So I need to break this up and go every 0.75. So I need to start at 1, go 0.75 forward and be 1.75, go another 0.75 forward and be 2.5, another 0.75 forward and be 3.25, and then another 0.75 forward at 4. So I've marked those as my important values. Even though I might have a scale going up by 1s, I want to mark the values that I need for my cosecant graph. So at those green values that I plotted, those would be the 5 points and asymptotes. A cosecant graph, remember the cos are the ones that start with an asymptote. So I need to start with an asymptote here. I need to end with an asymptote. And cosecant has one in the middle. That's because for a cosecant graph, what we have is we have it starting with an asymptote. Then we're going to be on the upper guideline, then an asymptote, then on the lower guideline, and then back at the asymptote again. So we have an upper U shape this way, an upward U, and then a downward U shape here. I didn't draw this far enough down here, so I'm kind of overlapping some of my work, but you get the idea that there would be a downward shape U here. We'll just move these out of the way. Yeah, there we go. So an upward U, a downward U, that's one full cycle of that cosecant graph. And that's all we really need to plot. We know we can plot some more, do some more upward and downward U shapes as we go over there.